Article 344.26 permits up to the equivalent of 4/4 bends between pull points. Limiting the number of bends between pull points to 3 is a practical solution. This approach balances the ease of wire pulling with code compliance. While Article 344.26 allows up to 4 bends, pulling wire through that many bends can be challenging, especially for larger conductors. The spacing between pull points affects the difficulty of wire pulling. The bend radius of the bends also affects the difficulty of wire pulling. Smaller bend radii make wire pulling more difficult. Closer pull points also make wire pulling more difficult. Codes provide minimum requirements. Practical considerations often guide design decisions. Balancing code compliance with installer ease is important. Balancing code compliance with project efficiency is also important. It is essential to communicate your concerns and rationale to the reviewer. Explain the industry design practice. Explain the challenges associated with 4 bends. It may be possible to negotiate a compromise. You could allow 4 bends in certain situations. You could limit them to 3 in others. It's recommended to limit the number of bends between pull points to 3 for ease of wire pulling. If the reviewer insists on maximizing bends per code, communicate your concerns. Explore potential compromises. The number of bends in a conduit run affects the pull-in tension required to install conductors. Exceeding the allowable number of bends or having bends that are too sharp can damage the conductor insulation during installation. The National Electrical Code, or NEC, specifies the maximum number of bends allowed in a conduit run between pull points to prevent damage to conductors and to ensure that they can be easily pulled. The NEC permits a maximum of 360 degrees of total bend, which is equivalent to 490-degree bends between pull points such as conduit bodies, junction boxes, or pull boxes. This limitation is outlined in NEC Section 344.26 for rigid metal conduit, Section 352.26 for rigid polyvinyl chloride conduit, and similar sections for other conduit types. The purpose of this limitation is to prevent excessive pulling tension on the conductors, which can damage the insulation and make it difficult to install the conductors. If a conduit run exceeds 360 degrees of total bend between pull points, additional pull points must be installed to reduce the pulling tension. There are several factors to consider when determining the appropriate number of bends for a conduit run. Firstly, the size and type of conductors being installed can affect the pulling tension. Larger conductors and conductors with thicker insulation require more force to pull through a conduit. Secondly, the length of the conduit run can also affect the pulling tension. Longer conduit runs require more force to pull the conductors. Thirdly, the type of conduit being used can affect the pulling tension. Different types of conduit have different coefficients of friction, which affect the amount of force required to pull the conductors. In addition to the NEC requirements, it is also important to consider industry best practices when designing and installing conduit runs. Many experienced electricians and designers recommend limiting the number of bends to 390-degree bends between pull points to ensure that the conductors can be easily pulled and to minimize the risk of damage to the insulation. This practice is especially important for larger conductors and longer conduit runs. The radius of the bends in a conduit run can also affect the pulling tension. Smaller bend radii require more force to pull the conductors around the bend. The NEC specifies minimum bend radii for different types of conduit to prevent damage to the conduit and the conductors. The minimum bend radius is typically expressed as a multiple of the conduit diameter. For example, the NEC requires a minimum bend radius of 6 times the conduit diameter for rigid metal conduit. In addition to the NEC requirements and industry best practices, it is also important to consider the specific requirements of the project when designing and installing conduit runs. For example, some projects may have specific requirements for the number of bends allowed in a conduit run or the type of conduit to be used. It is important to review the project specifications and drawings carefully to ensure that the conduit runs are designed and installed correctly. When faced with a situation where a reviewer is asking to maximize the number of bends per code, it is important to communicate your concerns and rationale to the reviewer. Explain the industry design practice of limiting the number of bends to 3 and the challenges associated with pulling conductors through 4 bends. It may be possible to negotiate a compromise, such as allowing 4 bends in certain situations but limiting them to 3 in others. It is also important to document your concerns and the rationale for your design decisions in case there are any issues during the installation process. In summary, the NEC permits a maximum of 360 degrees of total bend between pull points, but industry best practices often recommend limiting the number of bends to 390-degree bends to ensure that the conductors can be easily pulled and to minimize the risk of damage to the insulation. When designing and installing conduit runs, it is important to consider the size and type of conductors, the length of the conduit run, the type of conduit being used, the radius of the bends, and the specific requirements of the project. The National Electrical Code, or NEC, provides specific guidelines regarding the installation of conduit, including the number of bends allowed between pull points. Pull points are locations where the conductors can be accessed, such as junction boxes, pull boxes, or conduit bodies. The purpose of limiting the number of bends is to prevent excessive strain on the conductors during installation, which could damage the insulation and lead to future electrical problems. According to the NEC, the maximum number of bends allowed between pull points is equivalent to 360 degrees, which is typically achieved with 490-degree bends. This requirement is outlined in NEC sections such as 344.26 for rigid metal conduit, 352.26 for rigid polyvinyl chloride conduit, and similar sections for other types of conduit. However, it's crucial to understand that the NEC provides minimum safety standards, and industry best practices often recommend more conservative approaches. In many cases, limiting the number of bends to 390-degree bends is considered good design practice. This approach offers a balance between code compliance and ease of installation, particularly when dealing with larger conductors or longer conduit runs. When a reviewer or client insists on maximizing the number of bends per code, it's essential to engage in a constructive dialogue to explain the potential challenges and benefits of alternative approaches. Firstly, discuss the increased difficulty of wire pulling with 4 bends. The more bends in a conduit run, the greater the friction and strain on the conductors. This can make it more challenging to pull the wires, especially for long runs or when using larger conductors. Secondly, emphasize the potential for insulation damage. Excessive strain during wire pulling can damage the conductor insulation, leading to shorts, ground faults, or other electrical hazards. Limiting the number of bends reduces the risk of insulation damage. Thirdly, highlight the increased labor costs. The more difficult the wire pulling process, the more time and labor required for installation. Limiting the number of bends can reduce labor costs and improve project efficiency. Fourthly, consider the long-term maintenance. Complex conduit runs with numerous bends can be more difficult to maintain or modify in the future. Simpler designs with fewer bends are easier to access and work with. When communicating with the reviewer, present a well-reasoned argument based on these factors. Explain that while the NEC allows for 4 bends, practical considerations often dictate a more conservative approach. Provide examples of situations where limiting the number of bends has resulted in smoother installations and reduced the risk of problems. In some cases, it may be possible to negotiate a compromise. For example, you could propose using 4 bends in shorter, less complex runs, while limiting the number of bends to 3 in longer or more challenging runs. Alternatively, you could suggest using larger conduit sizes or pull boxes to reduce the strain on the conductors. It's also important to ensure that the conduit bends are properly executed. The NEC specifies minimum bending radii for different types of conduit to prevent damage to the conduit and conductors. Using proper bending equipment and techniques is essential to ensure that the bends are smooth and consistent. In addition to the number of bends, the spacing between pull points can also affect the ease of wire pulling. Closer pull points reduce the length of the conduit run between access points, making it easier to pull the conductors. However, closer pull points may also increase the overall cost of the installation. Ultimately, The decision of how many bends to use in a conduit run should be based on a careful assessment of the project requirements, the size and type of conductors, the length of the conduit run, and the available space. By considering these factors and communicating effectively with the reviewer, it's possible to arrive at a solution that balances code compliance with practical considerations and ensures a safe and efficient installation. Furthermore, consider the impact of conduit fill. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. Exceeding the allowable conduit fill can make wire pulling more difficult and increase the risk of insulation damage. When designing a conduit run, it's essential to calculate the conduit fill to ensure that it complies with the NEC requirements. The NEC provides tables that list the allowable conduit fill for different types of conduit and conductors. When calculating conduit fill, it's important to consider the size and type of conductors, as well as any other items that may be installed in the conduit, such as grounding conductors or control wires. If the conduit fill exceeds the allowable limit, you may need to increase the conduit size or reduce the number of conductors. In addition to conduit fill, the type of lubricant used during wire pulling can also affect the ease of installation. Wire pulling lubricants reduce friction between the conductors and the conduit, making it easier to pull the wires. There are many different types of wire pulling lubricants available, each with its own unique properties. When selecting a wire pulling lubricant, it's important to consider the type of conductors being installed, the type of conduit being used, and the environmental conditions. Some lubricants are better suited for certain types of conductors or conduit, while others are more effective in extreme temperatures or wet environments. It's also important to follow the manufacturer's instructions when applying wire pulling lubricant. Applying too much lubricant can make the wires slippery and difficult to handle, while applying too little lubricant can increase friction and make wire pulling more difficult. Proper grounding and bonding are also essential for ensuring the safety of electrical installations. The NEC requires that all metal conduit systems be properly grounded and bonded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards and minimize the risk of fire. Grounding and bonding can be achieved by using grounding bushings, bonding jumpers, and other approved methods. It's important to follow the NEC requirements and industry best practices when grounding and bonding conduit systems. In addition to the technical aspects of conduit installation, it's also important to consider the aesthetic appearance of the finished product. Conduit runs should be installed in a neat and professional manner with all bends and fittings properly aligned. Exposed conduit runs should be supported at regular intervals to prevent sagging or damage. The choice of conduit material and finish can also affect the aesthetic appearance of the installation. Different types of conduit are available in a variety of colors and finishes to match the surrounding environment. By paying attention to the aesthetic details of conduit installation, it's possible to create a finished product that is both functional and visually appealing. Finally, it's important to remember that electrical work can be dangerous. Only qualified and experienced electricians should perform conduit installation and other electrical tasks. Always follow safe work practices and wear appropriate personal protective equipment, such as gloves, safety glasses, and hard hats. Before starting any electrical work, always energize the circuit and verify that it is safe to work on. By following these safety precautions, it's possible to minimize the risk of electrical accidents and injuries. When dealing with a reviewer who insists on maximizing the number of bends per code, it's important to document your concerns and the rationale for your design decisions. This documentation can be helpful if there are any issues during the installation process or if there are any future questions about the design. The documentation should include a detailed description of the conduit run, the number of bends, the size and type of conductors, the conduit fill calculations, and any other relevant information. It's also a good idea to obtain written approval from the reviewer for any deviations from industry best practices. In addition to documenting your concerns, it's also important to communicate effectively with the other members of the project team, such as the engineers, architects, and contractors. By working together and sharing information, it's possible to ensure that the electrical installation meets the needs of the project and complies with all applicable codes and standards. In conclusion, the number of bends allowed in a conduit run is governed by the NEC, but industry best practices often recommend more conservative approaches. When designing a conduit run, it's important to consider the size and type of conductors, the length of the conduit run, the conduit fill, the type of lubricant, the grounding and bonding requirements, and the aesthetic appearance of the finished product. By following these guidelines and communicating effectively with the project team, it's possible to create a safe, efficient, and aesthetically pleasing electrical installation.